This is section 1-2, use segment and congruence. So again, there's some vocabulary in this section, so make sure that you know that. So a postulate or axiom is a rule that's accepted without proof. Congruent segments are line segments that have the same length. So when we're talking about length of a segment, so if we had segment AB, okay, if we're actually talking about length of segment, we don't actually put the segment line over it. So length of AB, if it doesn't have the line over it, that's implied that it's the length. So again, line segments that have the same length. And you're going to see the symbol for congruent a lot. That is an equal sign with a tilde over it. So that's the congruent sign. Couple postulates. Postulate 1 is the ruler postulate. The points on a line can be matched 1-to-1 with real numbers, and then the real numbers that correspond to those points is the coordinate of the point. So like when you are using a ruler, say the end was broken off, so you lined up your point with 5 and 7 inches. So the distance between those 2 points written as AB, so like I was saying, the length between points is the absolute value of those distance. So the distance from 5 to 7, for example, absolute value of that is 2. Or you could have done 7 minus 5. Doesn't matter, either way you're subtracting and you're going to get 2. That's why we have absolute value, so it doesn't matter which way you line it up. You still get the same. So that's basically just saying we can measure the distance between 2 points, and if your ruler is broken, you don't have to necessarily start at 0. You could start at any number on your ruler, and the distance between them gives you length. The segment addition postulate is actually used a lot, especially later in this book. We're going to be doing some proofs, and you're going to need to know this one. So it might seem pretty basic today, but it's very, very important. So if B is between A and C, so let's say we have a segment, B is somewhere between A and C. Okay, then AB plus BC equals AC, which should make sense. If I add this part to the left of B with the part that's to the right of B, I should get the whole thing from A to C. Okay, and the opposite's also true. If they tell you AB plus BC equals AC, then B is somewhere in the middle. It doesn't have to be the exact middle. Okay, you could have B closer to A, okay, but it's somewhere between them. Either way, AB plus BC equals the whole thing of AC. So we can use that. Again, these might seem pretty basic, but try to think about why it works. So find the length. Remember, if it doesn't have the segment, that means find the length of xz. Okay, oops, forgot my G. So x to z. Well, we have 2 parts. We have the 23 part from x to y, and the 50 part from y to z. My segment addition postulate says I just need to add those together, and I will get the length of the whole thing. So I have 73 is my length from x to z. Now find the length of wx. So wx is just the smaller part, and we know by the segment addition postulate I can add this other part over here. So vw, which is 37, plus wx, the right part, equals the total thing of 144. So all I have to do is subtract 37 from 144 to get wx. So let's borrow. 13 minus 7 is 7. 13 minus 3 is 10. So wx is 107. So that's really the applications of the segment addition postulate when we have numbers. Again, they're pretty simple when you have numbers, but keep in mind we will be doing other things with those at some point. And that was it for section 1, 2, using the segments and congruence.